Hi, welcome to experiment number 7 in Data Communications Lab, and today we will design and implement a VLSM addressing scheme. So in the network topology, we have two routers and two switches. For the first router, BR1, we need 40 hosts here, and for the BR1 and BR2 link, we need 2 hosts. And for the BR2, it has 4 subnets, BR2 LAN, 25 hosts, BR2 IoT LAN for the future, 5 hosts, CCTV LAN, 4 hosts, and HVAC C2 LAN, 4 hosts. So for the objectives, Part 1, examine the network requirements. Part 2, design the VLSM address scheme. Part 3, cable and configure the IPv4 network. So for the short background, VLSM or Variable Length Subnet Mask was designed to avoid wasting IP addresses. With VLSM, a network is subnetted and then re-subnetted. So for part 1, examine the network requirements. So in this part, the network requirements develop a VLSM address scheme for the network that is displayed in the topology diagram using the 192.168.33.128 network address. Step 1, determine how many host addresses and subnets are available. So in a network that has a prefix of 25, so we are borrowing 1 bit on the 4th octet. So the remaining 0 bits, which is 7, will be used for the formula 2n. So 2 times n is equal to 128 host addresses. Then we will subtract the network and broadcast addresses. So 128 minus 2, which will equal to 126 usable host addresses. So what is the total number of host addresses needed in the topology diagram? So 40 plus 2 plus 25 plus 5 plus 4 and plus 4 is equal to 80. So how many subnets are needed in the network topology? 6, because 1, 2, 3, 4, 5, and 6. So step 2, determine the largest subnet. What is the subnet description for BR1 LAN or BR1 to BR2 link? So for BR1 LAN, we have 40 hosts. So this is the equivalent binary value of the subnet mask. So we will borrow 2 bits in the 4th octet. So 128 plus 64 is equal to 192. And for the BR1 and BR2 link, we need 2 hosts. So we will borrow 5 bits on the 4th octet. So 128 plus 64 plus 32 plus 16 plus 8 and plus 4, which will equal to 252. So this is the equivalent subnet mask. How many IP addresses are required in the largest subnet? BR1 LAN, 40 IP addresses or 40 hosts. What subnet mask can support that many host addresses? 255.255.255.192. And how many total host addresses can that subnet mask support? So the remaining 0 bits here in the 4th octet is 6. So 2 raised to 6 is equal to 64. Then subtract the network and broadcast address. So we have 62 usable host addresses. So can you subnet the 192.168.33.128 with prefix 25 network address to support this subnet? Yes. So what are the network addresses that would result from this subnetting? So 192 plus 168.33.128 up to 191. Then the first host address will be 192.168.33.129. Step 3, determine the second largest subnet. So BR2 LAN, we need 25 hosts. So we will borrow the first 3 digits on the 4th octet. So 128 plus 64 plus 32 is equal to 224. How many addresses are needed? 25. What is the subnet mask that can support that many host addresses? Here, 255.255.255.224. And how many total host addresses can that subnet mask support? So the remaining 0 bits in the 4th octet is 5. So 2 raised to 5 is equal to 32. Minus the network and broadcast address, we will have 30 usable host addresses. Then can you subnet the remaining subnet again? Yes. What are the network addresses that will result from the subnetting? So the last network address here is 191. So the first network address here will be 192.168.33.192. So the network addresses here in this subnet is equal to 192.168.33.192 up to 223. So the first host address here is 192.168.33.193. Then the broadcast address will be 192.168.33.223. Then step 4, determine the third largest subnet. So BR2 IoT LAN needs 5 hosts. So we will borrow the first 5 digits in the 4th octet. So 128 plus 64 plus 32 plus 16 plus 8, which will equal to 248. IP addresses required, 5. Subnet mask, 255.255.255.248. So how many total host addresses can the subnet mask support? The remaining 0 bits in the 4th octet is 3. So 2 raised to 3 is 8 minus the network and broadcast address. So we will have the 6 usable host addresses. So can you subnet this again? Yes. What are the network address that would result from this subnetting? The last network address is 223. So the first network address for this subnet is 192.168.33.224. So our network addresses for this subnet will be 192.168.33.224 up to 231 with prefix of 28. So the first host address here will be 192.168.33.225 and the broadcast address will be 192.168.33.231. Then use a second network address for the CCTV LAN. So BR2 CCTV LAN needs 4 hosts. So we will borrow 5 bits on the 4th octet. So 128 plus 64 plus 32 plus 16 plus 8 will equal to 248. And the remaining 0 bits in the 4th octet is 3. So 2 raised to 3 will equal to 8. Then minus the network and broadcast addresses. So we will have 6 usable host addresses. So the network addresses from the subnet will be 192.168.33.232 up to 239. So the usable host addresses will be from 233 up to 238. So that will be 6 usable host addresses. And the network address will end on 232 with prefix 28. And the broadcast address will be 239 with prefix 28. Then use the third network address for the HVAC C2 LAN. So it also needs 4 hosts. So we will borrow the first 5 bits in the 4th octet. So 128 plus 64 plus 32 plus 16 plus 8 will equal to 248. Remaining 0 bits is 3. So 2 raised to 3 is equal to 8. Minus the network and broadcast address. So we have 6 usable host addresses. So since the broadcast address here is 239, the first network address here will be 192.168.33.240 with prefix 28. Then since we have 6 usable host addresses, so the first host address will be 192.168.33.241 up to 246. The broadcast address will be 192.168.33.247. Then determine the 4th largest subnet, so the last one, BR1 to BR2 link, which only needs 2 hosts. So we will borrow the first 6 bits in the 4th octet. So that is 128 plus 64 plus 32 plus 16 plus 8 plus 4 is equal to 252. IP address required 2. One subnet mask can support that many host addresses. Here 255.255.255.252. Then since the remaining 0 bits is 2, so 2 raised to 2 is equal to 4. Minus the network and broadcast address, so we have 2 usable host addresses. So can you subnet this again? Yes. So what are the network addresses that would result from this subnetting? So the last broadcast address here is 247. So the first network address here will be 192.168.33.248. And the usable host addresses will be 249 up to 250. And the broadcast address will be 192.168.33.251. So once completed, we can proceed to part 2. Design the Vlsm address scheme. So based on what we did a while ago, this is the complete subnet information. So for the BR1 LAN, 40 hosts needed. Network address will be 192.168.33.128. First host address 129. Then the broadcast address will be 191. Then for the BR2 LAN, 25 hosts needed. Broadcast address here 191. So the network address here will be 192. Then the first host address will be 193. Then the broadcast address will end with 223. Then the network address here for BR2 IoT LAN, which needs 5 hosts, 224. Then first host address will be 225. Then for the broadcast address, 231. So BR2 CCTV LAN needs 4 hosts, 192.168.33.232. First host address will be 233. Then for the broadcast address, 239. Then for the BR2 HVAC C2 LAN, 4 hosts needed. Network address 192.168.33.240. Then the first host address will be 192.168.33.241. Then for the broadcast address 192.168.33.247. And for the BR1 and BR2 link, which needs 2 hosts, network address 192.168.33.248. Then the first host address will be 249. Then the broadcast address will be 251. So this is the summary of what we did a while ago. Then for step 2, complete the device interface address table. So assign the first host address in the subnet to the Ethernet interfaces. BR1 should be assigned the first host address in the BR1 and BR2 link. Based from the topology a while ago, for the Gigabit Ethernet 0, of BR1 will be assigned with the IP address of 192.168.33.249 here. Then the subnet mask of 255.255.255.252. Then for the gigabit Ethernet interface 0 of BR2 router, it will be assigned with an IP address of 192.168.33.250 with a subnet mask of 255.255.255.252 with the device interface description of BR2 to BR1 link. So we can observe here, we have the two usable hosts, 249 and 250, as we have calculated earlier. So first one is 249, then the next one is 250. Then for the Gigabit Ethernet 1 interface of BR1 router, 192.168.33.129 with a subnet mask of 255.255.255.192 with a device interface description of 40 host LAN. So we can see it here, the assignment, 128 network address, then the first host address will be 129. Then for the Gigabit Ethernet interface 1 of BR2, 192.168.33.193 with a subnet mask of 255.255.255.224 with the device interface description of 25 host LAN. So this is from here. So 25 host number needed, 192.168.33, then first host address 193 here. So there. So part 3, cable and configure the IPv4 network. So in this part, we will cable the network to match the topology. So we will configure the 3 routers using the Vlsm address scheme that we developed here in part 2. So now let's go to packet tracer. Here in the packet tracer, we have PC1 and PC2. Then we have BR1 and BR2, S1 and S2. Now let's put S1 here, BR1, then BR2, and S2. Then let's put PC2 here. Then we will connect the devices based on the network topology. So for switch 1, we will use the Fast Ethernet 05 interface to connect to BR2 Gigabit Ethernet 01 interface. So we will use a copper straight through cable. Then let's find Fast Ethernet 05 here. And let's connect it to G001. There. Then for the BR1 and BR2 link, G00 to G00 of BR2. Then another copper straight through G01 of the BR2 to F05 of switch 2. There. Then after that, we will establish a console connection to the PC. Then for the BR1 router, we will connect console cable here, console port, then connect to RS232 port of PC1. Then another console cable, console port of BR2 to RS232 port of PC2. Now after that, let's turn on our PC. Then let's turn on the routers. Turn it on. There. After that, step 2, configure the basic settings on each router. So we will assign the correct device name to each of the 2 routers. Assign class as privileged exec encrypted password. Console password Cisco. VTY password will be Cisco. Then we will encrypt plain text password for the routers and a banner MOTD. So now let's configure BR1 using PC1. Go to desktop terminal. Then let's go router enable config t hostname BR1 line con 0 password Cisco login exit line VT1 0 to 15 password Cisco login exit. Then enable secret class service password encryption. Then banner MOTD authorized access only. So let's check exit show run. So yeah, service password encryption hostname. Okay, then let's activate the interfaces. Show IP interface brief. So we will assign G001 or Gigabit Ethernet 0 and Gigabit Ethernet 01. So config t int G000 IP add 192.168.33.249 255.255.255.252. Description BR1 BR2 link. Now shutdown exit in G001 IP add 192.168.33.129 255.255.255.192. Description, 40 host LAN, no shutdown. Exit, show IP, int brief. So as we can see here, both gigabit Ethernet interfaces status were up. Then exit, Cisco, config T, enable, class, run. Then copy run start to save the running configuration to startup config. Okay. Now let's configure the interfaces in the BR2 router. So PC2, desktop, terminal, configuration, and turn, enable, config T, hostname BR2, line con 0, password, Cisco, login, exit, line, ETY 0 to 15, password, Cisco, login, exit, enable secret class, service, password, encryption, banner, MOTD, authorize, so exit, show IP, and brief. Let's see the interfaces. So both gigabit Ethernet traces are not yet configured. So config T, int G000 IP add 192.168.33.25D down 255.255.255.252. And description BR2 BR1 link, no shutdown. Okay, exit int G001 IP add 192.168.33.193 255.255.255.224. Description 25 host LAN, no shutdown. Exit, show run. Exit, show run. Okay, configured. Ito. And copy, run, start. Okay, we can see here that the completion is 100%. So for the step 5, test connectivity. So from BR1, we will ping G000. So from BR1, we will ping G000 interface on BR2. And from BR2, we will ping G00 interface on BR1. So from BR1, here, try. Ping 192.168.33.250. Time of 2 seconds. Success rate is 80%. Let's try again. Okay, 100%. And from BR2, let's ping G000 interface on BR1. So let's go to PC2 terminal. Okay. Then let's ping 192.168.33.249. Okay, success rate is 100%. Another. So let's check the results in the activity. Assessment items, network. Check. Okay, check. 100%. IP component 8/8, other 20/20, physical 13/13. So it's okay. Then, reflection question. Can you think of a shortcut for calculating the network addresses of consecutive? So we all know that subnetting with the prefix of 30 gives us 4 network addresses equals 2 usable host addresses, 1 network address, and 1 broadcast address. So for example, we have an IPv4 address of 192.168.1.0 and we want to subnet, and we have to subnet it with the consecutive prefix of 30. So for the first subnet, so let's go. Subnet D. So for the first subnet, network address will be 192.168.1.0. First host address will be 1. Then broadcast address will be, then the broadcast address will be 3. Then next one will be 4. Then 5. Then 7. 8. So we are just adding 4. So from the network address to broadcast address is just only 4 network addresses. So it's like there 10, 11, 12, then 14. So network address. So let's try to check. Insert. Last. Try to check. Okay. 10, and this will be 11, 4, 5, 6, 7, 8, 12, 13, and 14. This will be 16. So, there.